Let us now observe some more special features of this chapter. We know that tan of a plus b is equal to tan a plus tan b by 1 minus tan a tan b. Now you take a in the place of b, that is replace b by a itself. Then what happens? A plus a, 2a. Tan 2a is equal to tan a plus tan a, 2 tan a by 1 minus tan a into tan a, tan square a. This is the important result. And if you can replace a by theta by 2, what happens? 2 into theta by 2 is theta. Therefore, tan theta is equal to 2 tan theta by 2 by 1 minus tan square theta by 2. Well, my dear, students will be generally confused about these two formulae. Sin 2a is equal to 2 tan a by 1 minus tan square a, tan 2a is equal to 2 tan a by 1 minus tan square a, and sin 2a is equal to 2 tan a by 1 plus tan square a. They look similar, but with a slight difference. In the denominator it is 1 minus tan square a, there it is 1 plus tan square a. Well, my dear, how to get it remembered? Actually, sin 2a is 2 sin a cos a. We could have multiplied and divided with cos a, so that 2 tan a into cos square a will be obtained. If you send that cos square a to denominator, it becomes 1 plus tan square a. That is the reason. So 1 plus tan square a must be present while sin 2a is going to be obtained, and 1 minus tan square a must be used while using tan 2a. Okay, as usual, tan theta is equal to 2 tan square theta by 1 minus tan square theta by 2. Okay, another special formula regarding these tan thetas and tan 2 thetas is there. We shall look at that. We know that 2 sin square a is equal to 1 minus cos 2a. Why and how? We know that cos 2a is equal to 1 minus 2 sin square a. So 2 sin square a is equal to 1 minus cos 2a. And similarly, 2 cos square a is equal to 1 plus cos 2a. I think you can believe, you can recollect from where has it been obtained. We know that cos 2a is equal to 2 cos square a minus 1. You bring just that minus 1 to this side, so that 1 plus cos 2a is equal to 2 cos square a. Well, you divide this. Tan square a is equal to 1 minus cos 2a by 1 plus cos 2a. And if you can replace a by some theta by 2, you have tan square theta by 2 is therefore is equal to 1 minus cos theta by 1 plus cos theta. Automatically, cot square theta by 2 is equal to 1 plus cos theta by 1 minus cos theta. Cot square a is equal to 1 plus cos 2a by 1 minus cos 2a. If you want to have tan a, plus or minus under root 1 minus cos 2a by 1 plus cos 2a. If you want to have tan theta by 2, plus or minus root of 1 minus cos theta by 1 plus cos theta, the sign, that is either plus sign or minus sign, will be decided according to the quadrant in which the so-called angles which are involved there are included. Yes, that is the matter about this tan square theta by 2. Similarly, cot theta and cot 2 theta. We know that cot of a plus b is equal to cot a cot b minus 1 by cot b plus cot a. If you replace b by a itself, then cot of a plus a is nothing but cot 2a is equal to cot a into cot a, cot square a minus 1 by 2 cot a by 2 cot a. And similarly, if you can replace a by some theta by 2, what do you have? Cot theta is equal to cot square theta by 2 minus 1 by 2 cot theta by 2. This is about the formula regarding cot theta. Yes, another important concept is there in compound angles and multiple angles, a combination of those two concepts. Sine of a plus b plus c. You take b plus c as one factor, a plus say some theta. Let me call b plus c some theta. Now it occurs as sine of a plus theta. Sin a cos theta plus cos a sin theta. And theta is b plus c. Again you expand it using cos of b plus c and sin of b plus c. Then the answer will be sin a cos b cos c plus sin b cos a cos c plus sin c cos a cos b minus sin a sin is 5. This can also be written as sigma sin a cos b cos c minus pi sin a. Sin a cos b cos c, cos a sin b cos c, cos a cos b sin c. Yes, minus sin a sin b sin c. Well, if you can replace b and c by a itself, what do you have? Sin of a plus a plus a. Sin 3a is equal to, come on, sin a cos a cos a. Sin a cos square a, sin a cos square a, sin a cos square a. So it is 3 sin a cos square a minus sin cube a. Okay, again you can have cos square a as 1 minus sin square a, so that you have 3 sin a into 1, 3 sin a minus 3 sin cube a minus sin cube a minus 4 sin cube a. Therefore, sin 3a is equal to 3 sin a minus 4 sin cube a. 4 sin cube a. From this, of course, you can have sin cube a as 3 sin a minus sin 3a upon 4. That also you can make use of according to the necessity, according to the need of the question or need of the concept. You can use sin cube a is equal to 3 sin a minus sin 3a by 4. This way explains us how to get sin 3a, sin of a plus b plus c. Okay, in a similar fashion, let us have cos of a plus b plus c also. In a similar fashion, we can have cos of a plus b plus c also. Of course, here also, by taking b plus c is equal to some theta, it takes the form cos of a plus theta, cos a cos theta minus sin a sin theta, and cos theta it will again be expanded in the form cos of b plus c is equal to cos b cos c minus sin b sin c, and the sin theta, of course, sin of b plus c can be written as sin b cos c plus cos b sin c. By using all of them, this can take the form, this is equal to cos a cos b cos c minus cos a sin b sin c minus sin a cos b sin c minus sin a sin b cos c. You please recollect sin of a plus b plus c at this juncture. Sin of a plus b plus c is equal to sin a cos b cos c plus cos a sin b cos c plus cos a cos b sin c minus sin a sin b sin c. You have a comparative study, a comparative observation between these two formulae. In sin of a plus b plus c, first one is sin a, second one is sine B, third one is sine C, the remaining are cosine functions. And the last term contains all sine functions. The similarity is such terms will also be existing here also, of course with minus sign. All cosine functions, first function is cosine function, other two are sine functions. Second one is cosine function, other two are sine functions. The last one is the cosine function, first two are sine functions. Yes, this is the nature of sine of A plus B plus C and cos of A plus B plus C. Isn't it? Okay. Next one. From this, if you get cos A cos B cos C out, cos of A plus B plus C is equal to cos A cos B cos C into 1 minus tan B tan C minus tan C tan A minus tan A tan B. And from this, sine of A plus B plus C is equal to, again you get cos A cos B cos C out, sine of A plus B plus C is equal to cos A cos B cos C into sin A by cos A remains tan A plus tan B plus tan C minus tan A tan B tan C. Tan A tan B tan C. Well, my dear, you have both sin A plus B plus C and cos A plus B plus C at your disposal. You can have tan of A plus B plus C from here itself, tan of A plus B plus C. This by this. What happens is cos A cos B cos C will go away, leaving you tan A plus tan B plus tan C by tan A plus tan B plus tan C minus tan A tan B tan C by this 1 minus tan A tan B minus tan B tan C minus tan C tan A. So with the help of sine of A plus B plus C and cos of A plus B plus C, we are able to have tan of A plus B plus C directly. Isn't it? You please do not forget that both sine of A plus B plus C and cos of A plus B plus C could be written in terms of tan A, tan B and tan C. Of course, by getting cos A, cos B, cos C as a common factor out, you can remember even sine of A plus B plus sine of A plus B could also be written as cos A cos B into tan A minus tan B. Tan A plus tan B, isn't it? Even cos of A plus B plus, in cos of A plus B also you could have taken cos A cos B out to write in terms of tangents, I mean tan A and tan B. The similar thing could be repeated here also. So at a glance we are able to see all of them, sine of A plus B plus C, cos of A plus B plus C and tan of A plus B plus C at a stretch, at a glance. Yes, you please remember the style of getting them. What is sine of A plus B plus C? Three products of taking two at a time, of taking three at a time, sin A cos B cos C, sin B cos C cos A, sin C cos A cos B, minus all of them sin A sin B sin C. Whereas cos of A plus B plus C contains all cosine functions in the beginning itself, that is cos A cos B cos C minus sigma cos A sin B sin C. What will be the next term? Sin A cos B sin C. What will be the third term? Sin A sin B cos. Right. And from these two, if you could get cos A cos B cos C out, you will be having tan of A plus B plus C directly. Good. Next, let us make use of this formula and this formula to have cos 3a and tan 3a. Well, my dear, we have cos of a plus b plus c before us. It is there itself. Let us replace both b and c by a itself. What is going to happen? Cos of a plus a. Cos 3a is equal to cos a cos cube a. Cos a into sin square a, cos a into sin square a, cos a into sin square a. 3 cos a into sin square a. But you see, you can write sin square a as 1 minus cos square a, isn't it? So, in this, 3 cos a into minus cos square a is plus 3 cos cube a. 1 cos cube a is here, so that 4 cos cube a minus 3 cos a. You are going to get about cos 3a. Cos 3a. Of course, from this, you can have cos cube a directly. Cos cube a is equal to 3 cos a plus cos 3a by 4. That also you can make use of according to the necessity, according to the need of the question, need of the moment. Well, this could be derived from cos of a plus b plus c. Again, in tan of a plus b plus c also, if you can replace both b and c by a itself, what happens? Tan of a plus a. Tan 3a is equal to tan a plus tan a plus tan a. 3 tan a. Tan a into tan a into tan a. Tan cube a. 1 minus tan a into tan a. Tan square a, tan square a, tan square a. All together, how many tan squares are there? 3 tan square a. And this gives you, of course, tan of 3. We should feel happy both sin 3a, cos 3a, tan 3a, sin cube a and cos cube a are able to be obtained. And if you want to have tan cube a, it's not easy and it does not look nice, of course. If you get tan cube a from this, sin cube a by cos cube a, you add it, you use it. Then what is tan cube a? 3 sin a minus sin 3a by 3 cos a plus cos 3a. That's all. That is tan cube a. Well, let us now imagine the extension of this formula. Sin of a plus b plus c, you know. Sin of a plus b is okay. Sin of a plus b plus c plus d plus e plus f plus j etc. up to z. What happens? Sin of a1 plus a2 plus a3 plus etc. an. Cos of a1 plus a2 plus a3 plus etc. an. Tan of a1 plus a2 plus a3 plus etc. an. What happens to all these formulae? Is it possible to obtain them or not? It is now of special interest is that case. We shall look after that. Let a1, a2, etc. an be angles such that none of them is in the form 2n plus 1 into pi by 2. I am going to consider tan a1, tan a2, tan a3, etc., tan an. It is the need of the hour, the need of the question, need of the discussion. So to have tan a1 must not be equal to 2n plus 1 into pi by 2, isn't it? Just like that, I would like to consider with tan a1, tan a2, tan a3, etc., tan an also. So for that purpose, I should have none of a1, a2, etc. an is in the form 2n plus 1 into pi by 2. Okay, let us create some symbolism. Right. S1 is equal to tan a1 plus tan a2 plus tan a3, etc., tan an. I can write, let me write this tan A1 as 2 tan A1 into tan A2 plus tan A1 into tan A3 plus tan A1 into tan AN plus tan A2 into tan A3 plus tan A2 into tan A4 plus etc. tan A2 into tan AN, like that. That is sum of the products of tangents of these angles taken two at a time. Let me write this as sigma tan A1 tan A2 as 3 sigma tan A1 into tan A2 into tan A3 as 4 sigma tan A1 into tan A2 into tan A3 into tan A4, like that. What is S2? Sum of the products of tangents of the angles A1, A2, etc. AN taken two at a time. What is S3? Sum of products of tangents of the angles A1, A2, etc. AN taken 3 at a time. S4 taken 4 at a time. S5 taken 5 at a time. S6 taken as 6 at a time. Like that. You please represent. Now, we make use of this symbolism, of course, to have sin of A1 plus A2 plus etc., cos of A1 plus A2 plus etc., tan of A1 plus A2 plus etc. We shall be having. You please wait. I think you could have understood this symbolism, this style of representation. I think you could have understood it. My dear friends, my dear boys and girls, you don't forget, while obtaining this sign of A1 plus A2 plus A3 plus etc. AN, we are supposed to use the symbolism which we have just discussed previously. So for that purpose, none of A1, A2, etc. AN is in the form 2n plus 1 into pi by 2. You please do not forget it. Well, my dear, if n is 2, this is in the form sin of A plus B. Remember sin of A plus B? Tan A tan B into, cos A cos B into tan A plus tan B. Isn't it? Well, remember sin of A plus B plus C. That is n is equal to 3. Cos A cos B cos C into, isn't it? Cos A cos B cos C into tan A plus tan B plus tan C minus tan B tan C tan C. Tan A tan B tan C. So in every such thing, you are able to obtain product of cosines of the angles as a common factor before. In sin A plus B, you could have got cos A cos B out. In sin of A plus B plus C, you could have got cos A cos B cos C out. And in sin of A1 plus A2 plus A3 plus etc. AN, I am now getting cos A1 into cos A2 into cos A3 into cos AN into S1 minus S3 plus S5 minus S7 plus and so on. That is sin of A1 plus etc. Let us verify whether this formula is correct or not. Let me take n is equal to 2. Sin of A1 plus A2. What is sin of A1 plus A2? Cos A1 into cos A2 into tan A1 plus tan A2. Cos A1 into cos A2 into S1 is only meaningful. S3 has no meaning here. N is equal to 3. What is S1? Tan A1 plus tan A2. Correct. Next, let me take n is equal to 3. then LHS becomes sine of A1 plus A2 plus A3, isn't it? N is equal to 3 implies sine of A1 plus A2 plus A3 is equal to cos A1 into cos A2 into cos A3 into S1 minus S3. Is it right or not? What is S1? Tan A1 plus tan A2 plus tan A3. What is S3? Tan A1 into tan A2 into tan A3. We could have got the correct answer. Hence, this formula is verified for n is equal to 3 also. It is correct actually. In a similar fashion, cos of A1 plus A2 plus A3 and so on etc. plus an is equal to. Come on my dear, you remember what is cos of A plus B? Cos A cos B into 1 minus tan A tan B. Cos of A plus B plus C. Cos A cos B cos C into 1 minus tan A tan B minus tan B tan C minus tan C tan A. So in every such things, 1 minus, it is a fixed pattern. Okay, here also to construct or rather to form the formula cos of A1 plus A2 plus A3 plus etc. an, you can have this as cos A1 into cos A2 into cos A3 into cos an into 1 minus S2 plus S4 minus X6 plus etc. etc. Take n is equal to 2. Cos of A1 plus A2 is cos A1 into cos A2 minus 1 minus S2. That is 1 minus tan A1 tan A2. Correct. Take n is equal to 3. Cos of A1 plus A2 plus A3 is equal to cos A1 into cos A2 into cos A3 into 1 minus S2 only. S4 has no meaning. Why? Because we have taken n is equal to 3. Cos A1, cos A2, cos A3 into 1 minus S2. What is S2? Sigma tan A tan B. That is sigma tan A1 into tan A2. Correct. We have seen previously in the formula of cos of A plus B plus C. Well, this is also correct. Well, my dear, by making use of these two, you will be able to have tan of A1 plus A2 plus A3 plus etc. etc. an is equal to cos A1 into cos A2 into cos an will be cancelled. It is nothing but sine of A1 plus A2 plus A3 plus etc. an by cos of A1 plus A2 plus A3 plus etc. an. This by this. In that division, cos A1 into cos A2 into etc. cos an will definitely be cancelled, leaving you S1 minus S3 plus S5 minus S7 plus etc. 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 by 1 minus S2 plus S4 minus S6 plus etc. etc. Let us try to verify, my dear friend, for this formula also for n is equal to 2 and n is equal to 3. If n is equal to 2, tan of A1 plus A2. Tell me the formula. Tan A1 plus tan A2 by 1 minus tan A1 into tan A2. S1. S3 has no meaning. S1 tan A1 plus tan A2 by 1 minus S2 tan A1 into tan A2. Well, take n is equal to 3. If you take n is equal to 3, what will be LHS? Tan of A1 plus A2 plus A3. Tell me the formula. Tan A1 plus tan A2 plus tan A3 minus tan A1 tan A2 tan A3 by 1 minus tan A1 into tan A2 minus tan A2 into tan A3 minus tan A3 into tan A1. Let us see whether it comes or not. S1 tan A1 plus tan A2 plus tan A3. S3 tan A1 into tan A2 into tan A3. No question of S5. Stop there. Come to the denominator. 1 minus S2. What is S2? Sum of the products taken two tangents at a time. Tan A1 into tan A2, tan A2 into tan A3, tan A3 into tan A, minus of that sigma. Yes, we have got it. So these three formulas, a very good, attractive, useful, important combination of three main formulae in trigonometric ratios, of course, in which compound angles are involved. It's a beautiful bunch of formulas. You have a note of that. It is not enough if you just look at that. You may have to practice them, you may have to use them many times, you may have to remember them. Now we shall observe the special features of these three formulae, the specialities of these formulae. We shall now observe the special cases of those previous formulae. Let us recall what is sine of a1 plus a2 plus a3 plus etc. an is nothing but cos a1 into cos a2 into cos a3 into cos an into, come on, s1 minus s3 plus s5 minus s7 and so on. What happens if a1 is equal to a2 is equal to a3 is equal to an is equal to a? A plus a plus a plus a n times, what is that? NA. Cos a into cos a into cos a into cos a into cos a n times, what is that? Cos power NA. Now the actual thing comes before us. What is S1? Tan A1 plus tan A2 plus tan A3 plus etc. tan AN. But you see, A1 is equal to A2 is equal to A3 is equal to etc. AN, isn't it? So it is tan A plus tan A plus tan A plus tan A. How many times? N times. So it becomes N tan A. Minus. What is S3 actually? Tan A1 into tan A2 into tan A3 plus tan A1 into tan A2 into tan A4 plus, like that, sum of the products of tangents of the angles taken 3 at a time. How many such things are there? Tan A1, tan A2, tan A3, etc. tan AN. You are supposed to take 3 at a time. Out of n, you can take 3. How many ways? NC 3 ways. So in NC 3 products you have. But you see, every angle is A itself. Tan A, tan A, tan A. What is tan A, tan A, tan A? Tan cube A. NC 3 into tan cube A plus S5. Absolutely with the similar argument, tan A1, tan A2, etc. tan AN. There are n items. Out of those n, you can pick out 5 in NC 5 ways. So plus NC 5 products will be there. All those products are like this, etc. etc. This is the formula for sin NA. You can take n is equal to 2 and verify. Sin 2a is equal to cos square a into 2 tan a. Of course, 2 tan a by secant square a. 2 tan a by 1 plus tan square a. It's correct. If you take n is equal to 3, what happens? Sin 3a is equal to cos cube a into 3 tan a minus 3c 3 tan cube a. It's correct. Cos cube a into 3 tan a minus tan cube. Well, so this offers us the formula for sin NA. Good. This is the formula for sin NA. Now, let us try to have the formula for cos NA. Let us repeat. What is cos of A1 plus A2 plus A3 plus etc.? Cos A1 into cos A2 into cos A3 into cos AN into 1 minus S2 plus S4 minus S6 and so on. Use the same concept. If A1 is equal to A2 is equal to etc. AN is equal to A, then LHS becomes cos NA. is equal to cos A into cos A into cos A into etc. cos A. What is that? Cos power NA. S2. What is the meaning of S2? Tan A1, tan A2, etc. etc. tan A and n numbers are there. Out of them you are supposed to take 2 at a time. So how many ways? NC2 ways. NC2 into, in each product only 2 tangents will be there, tan A1 into tan A2, but we are taking A1 is equal to A2, etc. So tan square A, NC2 into tan square A. Automatically with the similar argument, the next term will be NC4 into tan power 4A. The next term will be minus NC6 into tan power 6A, and so on. This is the formula to have cos NA, to form or to have cos NA. This is the more suitable formula. Well, we have both sin NA and cos NA before us. Both are ready. Why can't we produce tan NA? We can. What is tan NA? This by this. Cos power NA will be disappeared. Then what happens? It is n tan A is nothing but NC1 tan A minus NC3 tan cube A plus NC5 tan power 5A minus and so on by one minus NC2 tan square A plus NC4 tan power 4A minus NC6 tan power 6A and so on. Do you want to have any verification about tan 2 or tan 3? You can put n is equal to 2. Tan 2A is equal to 2 tan A by 1 minus tan square A. No meaning of NC3, no meaning of NC4, isn't it? So 2 tan A by 1 minus tan square. 2C2 is 1. Verified. Do you want to have tan 3A from this? You can. Tan 3A is equal to 3C1 is 3. 3 tan A minus 3C3 is 1. Tan cube A. 3 tan A minus 3 tan cube A by 1 minus 3C2. 3 tan square. 1 minus 3 tan square. Absolutely correct. Therefore, this is the first formula, this is the second formula, and this is the third formula. Both sin NA and cos NA are made use of to have tan NA. Well, my dear, this is the special episode which offers us all the values of sin NA, cos NA and tan NA. Of course, to find them or to obtain them, we could have made use of sin of A1 plus A2 plus etc. AN, cos of A1 plus A2 plus etc. AN, tan of A1 plus A2 plus etc. AN. Yes, and these will be very much useful in the next chapters to come. What is sin theta plus sin pi plus theta? Sin theta plus sin pi plus theta plus sin 2 pi plus theta plus sin 3 pi plus theta plus etc. 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 sin n pi plus theta. What is the value of this? That is the next question. Actually, I would like to introduce you a standard result as a formula. It is one of the standard results. Look here. What is sin theta plus sin pi plus theta? Sin 180 plus theta minus sin theta plus sin theta 0. What is sine 2 pi plus theta? Sine theta. What is sine 3 pi plus theta? Minus sine theta. That is also 0. So like that you proceed, two terms, they become 0. Two adjacent sum of two adjacent terms is 0. What remains? Who knows? About the nature of n only we can take the decision. If n is odd, something happens. If n is even, something happens. Suppose n is odd. N is odd means the number of terms in this sum is even. Two terms, nothing will remain. Answer is 0. Answer is 0. Suppose n is even. Suppose n is even. Then here the number of terms will be odd. In such a case, n is even means you take sine 4 pi plus theta up to. You leave the first term, add these two. Sum 0, sum 0, like that. Sine theta will be remained. Sine theta will be remained. So we will be able to produce the result as follows. Sine theta plus sine of pi plus theta plus sine of 2 pi plus theta plus etc. Sine of n pi plus theta is equal to 0 if n is odd. Sine theta if n is even. The same result can again be stated as sigma sine of r pi plus theta, r is equal to 0 to n, is 0 if n is odd and sine theta if n is even. Sine theta if n is even. This is a beautiful result which can be used as and when it is required. These things will not be available in your textbooks. These are the things that you have to construct and use. In a similar fashion, you can use the result cos theta plus cos of pi plus theta plus cos of 2 pi plus theta plus cos of 3 pi plus theta and so on up to cos of n pi plus theta. Absolutely, exactly the similar fashion. This again becomes 0 if n is odd. Why? Because what is cos of pi plus theta? Minus cos theta and plus cos theta go away. Or you consider these two, cos theta minus cos theta. Sum of any two adjacent terms in this sum is 0. Therefore, this is 0 if n is odd, is equal to cos theta if n is even. Is even. This can also be represented as sigma r is equal to 0 to n cos of r pi plus theta is equal to 0 if n is odd and cos theta if n is even. This is the next beautiful result which we have. You have a note of that. Preserve that in your mind, in the memory box. To introduce the next concept, let us have the utility of that concept in the beginning by means of an example. What I mean to say is, we are going to learn a new concept. To learn that concept, let us exemplify that with a small problem. Look at this. Sin alpha plus sin beta plus sin gamma plus sin delta plus sin theta is equal to 5. Is equal to 5. Then the value of 3 sin alpha plus 4 sin beta minus 6 sin gamma plus 2 sine theta. How much? That is the question. Come on, try to get it answered. Are you getting any idea? One of the simplest ideas, of course, solves this problem. Look here, sine alpha, it can never exceed 1. It can never exceed 1. Any sine ratio, sine alpha, sine beta, sine gamma, sine delta, sine theta, every one of them, each of them can never exceed 1. But the total is becoming 5, isn't it? It happens when and only when each is equal to 1. 1, 1, 1, 1, 1. 3 sine alpha, 3. 4 sine beta, 4. 6 sine gamma, 6. 2 sine theta, 2. Total 3 plus 4, 7 plus 2, 9. 9 minus 6 is 3. 3 is the right answer. One more question. Based on the same data, then sine of pi by 2 plus alpha plus cos of pi plus beta plus tan of gamma minus pi by 4 plus cot delta by 2 plus cos theta is equal to how much? You may be stunned to look at that. The same data, of course, the same concept you can use. 1, 1, 1, 1, 1. Well, sine alpha is equal to 1. You can take alpha as pi by 2. Sine of pi by 2 plus pi by 2. How much? 180. Sine 180, 0. Cos of pi plus pi by 2. 180 plus 90, 270. Cos 270, 0. Gamma is pi by 2. Pi by 2 minus pi by 4, pi by 4. Tan pi by 4 is 1. This part becomes 1. Cot of delta by 2. Delta is pi by 2. Delta by 2 is pi by 4. Cot pi by 4 is 1. Cos theta. Theta is pi by 2. Cos theta is 0. So, at last what has been remained? It is 2. Answer is 2. So, in all such problems, what is the concept that must be kept in mind? Sum of sine functions is 5. There are 5 sine functions. If at all such thing happens, each of the sine function becomes 1, and each of those angles can be taken pi by 2. Okay? Yes. Let us now generalize this result. Sin A1 plus sin A2 plus sin A3 plus etc. sin AN is equal to n. Then sin A1 is equal to sin A2 is equal to sin A3 is equal to sin A4 is equal to sin AN is equal to 1. Automatically, you need not write it here. If sin A1 is equal to 1, A1 can be taken as pi by 2, isn't it? Cos A1, similarly, cos A1 plus cos A2 plus cos A3 plus cos A4 plus etc. cos AN is equal to n. Then cos A1 is equal to cos A2 plus is equal to cos A3 is equal to etc. cos AN is equal to 1. It does mean that A1 might be 0 or 2n pi. A1 is equal to A2 is equal to A3 is equal to etc. A1, A2, each of A1, A2, A3 etc. AN will be of the form 2n pi. 2n pi. Then only that becomes 1, isn't it? Yes. Of course, for the sake of clarification, you can take 0 or 2 pi, something like that. Yes. These two are beautiful results which are widely in use. Yes, it is an excellent matter. Well, my dear friends, there is exactly one more such result is here. We shall be looking at that. These will not be involved, these will not be given in your textbooks. You must be looking for them, you must be thinking of them, and you must be able to deduce them, yes, to use them as and when they are needed. The next concept rather, to introduce that, let us try to observe one example regarding the same. Look here. If theta is not equal to n pi and sin theta plus cosecant theta is equal to 2, then sin power 10 theta plus cosecant power 10 theta is equal to dash. There are certain options. First option 1, second option 2, third option 2 power 10, fourth option none. What is the basic concept involved in this problem? In calculus, while dealing with the maximum and minimum values of functions, you might have observed the function f of x is equal to x plus 1 by x. X plus 1 by x. What is the range of this function? The range of this function is minus infinity to minus 2 union 2 to infinity. As and when you look at a function in the form x plus 1 by x, of course x not equal to 0, x not equal to 0, and that is the discussion of the domain of this function. Of course it will be given in the problem itself. What is the range of this function? Minus infinity to minus 2 union 2 to infinity. If x happens to be negative, it has the maximum value minus 2. If x is positive, then it has the minimum value 2. So at any case, it can never lie between minus 2 and 2. And moreover, it attains the minimum value 2 only when at x is equal to 1 it attains the minimum value. It attains the maximum value minus 2 at x equal to minus 1. Well, what do you say about sin theta plus cosecant theta? It's just nothing but sin theta plus 1 by sin theta. Is it not in the form x plus 1 by x? Of course, we are given this theta not equal to n pi. So sin theta can never be 0. It definitely takes the form x plus 1 by x. He is saying that it is 2. Surely sin theta is positive. So its minimum value is 2. Minimum value of sin theta plus cosecant theta is 2. And the so-called minimum value is obtained only when x equal to 1 for this, sin theta is equal to 1 for that. Therefore, sin theta is 1, 1 power 10 is 1. Cosecant theta is also 1. Sin theta is 1 means cosecant theta is also 1. No? So, 1 power 10 plus 1 power 10, that is 2 is the right answer. And innocent people may tend to approach this third option. I'm sorry to say that this is the correct option. The answer is 2. Oh, like this, so many questions will be asked. Tan theta plus cot theta is equal to 2. What is tan power 10 theta, cot power 10 theta? Cos theta plus secant theta is equal to 2. What is cos theta minus sin theta? Like that. We can be asked such questions. Yes, so basic principle is this. If at all any function looks like f of x equal to x plus 1 by x, f of x equal to x plus 1 by x, then it can never lie between minus 2 and plus 2. If x is positive, then it is greater than or equal to 2. If x is negative, then it is less than or equal to minus 2. And if it is exactly 2, then x must be 1. If it is exactly minus 2, then x must be minus 1. Well, my dear, at this question, if I write like this, then what is the answer? If sin theta plus cosecant theta is minus 2, then what happens? Sin theta is minus 1, cosecant theta is minus 1. Minus 1 whole power 10 is 1. Minus 1 whole power 10 is 1. Then also the answer is 2. Of course, if at all this power is an odd number, if I ask you to have sine power 5 theta plus cosecant power 5 theta, then the answer becomes minus 2. Answer becomes minus 2. Well, my dear, what are the things that must be learnt, from this question? If at all there is any function in the form f of x is equal to x plus 1 by x, then it can never lie between minus 2 and 2.